Hello and welcome back to another LeetCode video. We're looking at LeetCode 3456, find special substring of length k. This is an easy problem, and as usual, we're going to use the problem to practice the interview process. And that means we're going to focus on problem solving, communications, and finding a solution before we write any code, including runtime and space complexity analysis. Just as you would do in a normal interview. And easy problems are very well suited for practicing this process because they tend not to get into the way when you need to think hard what the solution might be. So that's why they have a valid place in interview practice preparation. And yeah, let's without further ado, let's just get into this one. So we are given a string s and an integer k as inputs, right? And we should determine if there exists a substring of length exactly k in S that satisfies the following conditions. So substring of length k. Okay. The substring consists of only one distinct character. So it consists of only repeating characters. If there is a character immediately before the substring, it must be different from the character in the substring. And if there is a character immediately after the substring, it must also be different from the character in the substring. Interesting. So I guess if we have a string that starts with only repeating characters, those repeating characters are not a valid substring according to our definition. Okay. And we must return true if such a substring exists. Otherwise, we should return false. Okay, so in an interview, I would now ask the question of what does the input and exactly look like. We already know that we need to return a Boolean value. That's fine. Otherwise, we would have to clarify what the expected return or output should be. Most people forget to ask that, by the way, in an interview. So that's a good tip to keep in mind. And I would want to know whether the string s can be empty. Can it be a nil reference? What about k? Can k be 0? Or is it always guaranteed to be an integer that is larger than 0? Is it maybe larger than the length of the string? Things like that. So, and on LeetCode, you get an answer to those questions by looking in the constraints section. So, and it tells us that k is at least 1 and the length of the string is also at least 1. Furthermore, s consists of only lowercase English letters, which is okay, which is also good to know. And which should have been a question as well, what characters are in S. Cool. So with that out of the way, the next step is to look at the examples. And the purpose of doing that is to get a better feeling of what this problem is about. And also to see if you can come up with a systematic way of solving the problem. Unless you've seen a problem before, it's often very difficult to come up with a solution. So working through the examples is kind of the secret to unlock the problem and to find solutions that you didn't know before. It's a really crucial step. So even if it's an easy problem, I recommend you practice that process with that problem. So let's have a look at the first example. So here input string is S and it consists of A, B, and lots of A. So I would say the substring is now B, right? Because it has one distinct characters and it has different characters before and after. So I think B is the result. And K equals 3 means, wait a second. What was K again? A substring of exactly length K. Okay, so then B is not a valid substring because it doesn't match the length requirement. So why do we return true? Let me see. The substring S from index 4 to 6, so 0, 1 to 4. Wait, 0, 1, 2, 3, 4. So this AAA at the end of the string matches the conditions. Interesting. So I think what I said before then was wrong. So if there is a character immediately after the substring, must be present. So because there is none after, that's a valid substring because the one before is a valid one. Okay, interesting. So, right, so actually the AAA would also be a possible solution because it says if there's a character before, it must be different. But if there's none, it doesn't have to be different, just the one after. Okay, so good that I looked at the examples because they clarified my assumptions further. Right. Now example 2. So now we have A, B, C and K is 2. So we need to find a substring of length 2 that has only one distinct character, and that doesn't exist. So that's why we return false in this case. Interesting. Okay. So what I'm thinking about right now is like a sliding window approach where we keep a left pointer to the start of our window and maybe a right pointer to the end of our window. And we expand our window every time the next character is the same as the one in our window, which interestingly reduces the space complexity to store what's in the window to 1 because we only want one distinct character in there. And as soon as we encounter a new character that has a different that is different from what is on our window, we need to contract our window again. But first, before we do that, we actually check of whether the character before our window was different than the character in our window. And if it was, or if it's none, then we also check the length of the window. And if that matches, I think then we can return already true. So we will iterate over the array with the left and the right pointer, and the difference between marks the window. And yeah, we just need to check, whenever we encounter a new character, well, do we actually have a valid window of length k that only contains one distinct character, matching the requirements with characters before and after, and then we return true. And if we don't find something like that, then in the end we will return false. So that would be my suggestion, and the runtime and space complexity for that would be O of n time and O of 1 space, because we only need to keep track of pointers and window size. And yeah, and in an interview, I would now ask the interviewer if that's a good approach, whether I should do that. Maybe they ask if there are other different approaches, and then I could say, yeah, I could just check every possible substring. That would be O of n time, and O of n squared time, and to build them, would be O of n space. That would be less efficient, blah blah blah. So, and then they say, yeah, it's fine. Let's implement the more efficient solution right here. So what I would do is I would have a left pointer. We'd have a window. That would be a set that contains our character in the window. And strictly speaking, we could also just use a variable instead of a set, because we know there's only going to be ever stored one value in there. But let's keep it this way. So now we iterate over all of the elements in the string S. Right, and the character is, of course, S at position right. So now what we have to do, we have to add that character to our window. And now we have to contract the window when? Well, whenever the window has more than one character in it. So while length of window is larger than 1, going to remove the character at the left position, and we're going to increase the left pointer by 1. So that is now the contracting of the window. And so what that now does is this gives us a valid window. So it contains only one distinct character after we've done this contractions. But we have to check whether it contains the right size. So, well, how do we determine the size? Well, the difference between the right and the left pointer, right? So right minus left. If that is equal to k, that is exactly the window. Now we need to perform the check. What are the characters before and after the window? So what we do is, well, if left is larger than 0 and right is smaller than the length of the string minus 1, then we just have to check if the character to the right is not in the window, right? So if character to right position +1 not in window, then we return true. Otherwise we return false. So why does this work? Well, if we have a window of size k, and if we iterate, so what we check is, think about this. Yes, we want to be able to check if we check if left is 0 or no. The one thing to check is if left is larger than 0, that means that it is guaranteed that that at position left -1 is a different character than what is in the window. Otherwise, we would have never contracted the window and increased our left pointer, right? So if that is the case, then we can check if the next position is unequal, right? So if left is larger than 0, we can do that. However, if we don't even, I don't think we even have to check if left is larger than 0, because what if left is 0? Then we don't have a character immediately before it, right? So we don't have to check. Now, also, if the window is size k and it matches the entire string, so the question is now, is a substring, is S the substring of itself? Yes or no? And that should have been a clarifying question that I asked earlier. But I think what I can do is, if yes. I'm thinking of what are the different cases? And I should have maybe thought this out a little bit earlier. So we could have the case if left is equal to 0. And then we just check, whether the next right character is not the same as what we have in the window. And then we return true. Now the other case is if right is equal to length s minus 1. That means now our window spans the entire length of the string s. And we should probably return true, right? Because there are no characters immediately before and no characters immediately after. Now, what are the other cases? Well, if left is larger than 0, then we know that the character to the left is actually different. So in both of these cases, I think we have to perform exactly the same check. So I think we could simplify that, if I'm not mistaken, to this simple check. All right. I think we should put it to the test. Let's run through the test cases. Built-in function window remove does not work because I have a square bracket where it should be a curly, a round one. Remove s at left. Cool. Let's try again. So we're failing in this case. Why do we fail? Expected true, but we return false. Why is that? Right, so left is going to be 0. BAA, so it's going to be 3 and yeah, I think we need to perform this little check. So if left is larger than, if left is larger than 0, and right is smaller than length s, then we perform the check if the right is in the window or not. Yeah, I think my logic previously was flawed. I think that would solve that. So now when we check if it's larger than 0, so obviously we're going to ignore the first one, but we're going to match the second one. And if that is left is larger than 0, and right is not in the window, checking here, right, adding that. And we're actually not reusing C anywhere, so I could just put the length of the window is larger than 1, then we're removing the left, we're increasing the left, then we're computing the difference, and we don't have an off by 1 here because the last step was to increase left, so that's fine. And when left and right are the same, the size of the window is 0 anyways. Sorry, it's left and right can never be the same because we would not contract in that case. So yeah, so that is correct. Now we check if left is larger 0 and right is smaller than. I think that should work. So let's run through the tests, and we're still getting false. Okay. Debugging time. So this can happen in an interview, right? So you really need to be careful with your logic. So when you run through this, you want to continue to explain to the interviewer what exactly you're doing. So let's see. So what I'm doing now is, well, I would add some debugging output. So what I would do is I would say print to understand my logic better. So I would want to print what is the current window, right? So maybe we'll add something like this, window. And then what we do is we print the string s from left to right and +1 because the end is not inclusive in Python. So that's what we want to do. And we also want to print the length. So right minus left, and that should be our value k. And I'm going to comment the rest out. So let's run this to see what kind of output we get. Okay, so let's see. Input. Do not see any output at all. Right minus left equals 0, so we never see that. Maybe we should print this here. I was complaining about an empty if block. Again, I'm trying to continue to speak. So let's see. So we have a window A. So now, so we actually, it looks like we do have an off by 1 error. So the window size is, so what we have to do is we have to add 1 here. I think that was a big logic error that we had. So now let's try again. And that can happen, you know, depending on your performance on the day. What you will do, what you will have is, you know, sometimes you're weaker, sometimes you're stronger. So you have to have kind of techniques to cope with that. And for me, it's, you know, adding output to understand what's going on in the code. If I'm on fire, you know, I would probably do all the debugging mentally and find the solution. But it's perfectly viable to add debugging output. You want to maintain a systematic approach. That's the key point. Because you can still get points for how you talk, how you approach the problem, how you approach the debugging. All of those are extra points. Even if you don't get the best score, you're still giving a lot better feedback and signal when you can show grit and don't lose your communications and your approach when you run into unforeseen circumstances. Actually, it's one of the best ways to get a signal from a candidate is to see what does the candidate do when the candidate struggles. So this is now another opportunity to get points. That's how you should see this, not as a failure. And it's also training for what do you do when, you know, something goes wrong. And in the end, you know, you don't have to have a perfect performance. You just need to be better than the other candidates, right? So try to maintain a high level regardless of what your situation is. And it's also fine to say that you're completely stuck and you don't know how to solve this particular issue. All of these are things that are expected behaviors on the job later on as well, right? They don't want somebody to go silent when they don't know how to solve a problem. They want somebody who communicates what the problems are and the ideas that they had and all of those things. So yeah, so that's why I'm keeping this in the video. And just to drive home the point that you should practice this. It's not the end of the world. Okay, so now we have all the different windows, and we can see we get our window of with the 3 A's from the prefix and from the postfix. That's great. So now we have to check our assumptions. So what we have to do now as well, we know that regardless of what the left position is, if it's greater than 0, we know that there was a character before that is not in the current window. If it's equal to 0, there's no character immediately before it. So that's fine. So we can ignore that completely. So all we need to do is we need to check if well, if the right position is less than the length of the string, then we can check what the next character is, right? So that's what this logic would do now here. And however, our substring could also span over the entire array. So, right, so we should probably combine this. So if the next character is not in the window, we should probably return true. But also if right is equal to the length of the string -1, we should also return true, because that is case 3. There are no immediate characters after the substring anymore. And we know that regardless of what left is, there's not going to be a character that is the same as the current character in the window before the substring. All right, so let's try this approach now. Okay, cool. So it passes the test case. And yeah. I'm wondering whether I can write that a little bit more beautiful. Yeah, I could write it like this. If right is not exactly the length of the string, well, the other case is that it exists, right? That sorry, not exists, that it is less than the length of the string. So there we can just check if the next character is in the window or not. So that wouldn't change anything. So let me run the tests again, and I removed my debugging output for this. And the result is still the same. And so now I'm ready to submit it to see if it passes all of the secret test cases that LeetCode has for us. And and we see an error here. Window remove left. Let's see. So we have this string left, and our value for k was k. So I'm adding this as a test case. So now why would that happen? Key error k. So it's trying to remove a character from our window that is not in the window. Yeah, and that is because we have multiple of those k's in the window, right? I see. So actually our logic of the while loop is also flawed. So what we do is we just put one character in it, but as soon as we remove 1k, it's no longer in it, which is kind of super duper annoying, right? So maybe we should turn our window into a hash hash map that keeps track of the count of how many times we have a window in there. So let's use a default dict. So this is actually, so if you did all of this in an interview, that's not going to be great. But just for the purpose of illustration, let's just keep that in there. So what we will have in a window, we would actually increase the count of, well, we keep it a counter of how many times we have an item in the window. So what we do now is we just, we add the new character to the window. And when we remove them, we just decrease the count of that character. sleft count minus equals 1. Now we should also check, if we reach 0, we're just going to delete that character from the window entirely, so that we can use the length of the window again as how do you say, a test. So now, again, I feel very good about this now, and let's just run it through the test case, including the test case that we got from the failing submission. Okay, so now it passes where it failed before. Cool. And now since what our little change here with the default dictionary didn't change the runtime or space complexity, simply because we're only going to contain one element in our window. As soon as we have 2 elements in it, we're going to remove, we're going to iterate in the while until we have only 1 again. So let's submit this now and see if that. Right, so, and that passes. And I think that is an optimal time and optimal space solution, because obviously we have to iterate over all of the characters in the string. We got away with using only constant space. That is because we only need to remember what is the current character in our window. We had a problem with the logic. We had an off by 1 error with the left and right, where we forgot to add the +1 to determine the length. We also had to think a little bit about what are exactly the boundary conditions, but I think we came up with the right one, where we can completely discard checking the left pointer. As soon as we know that we have a window of the right size, we just need to check whether the next character after the right pointer is different or whether we've reached the end of the window. And finally, we found that using a simple hash set does not work. We actually need to keep track of the frequency of the character in our window so that we can correctly contract it again as soon as we run into a different character than a character that is repeated in our input. All right, and well, overall, so I guess this was more a demonstration of what to do when things go wrong. You've seen the technique of just adding debugging output to get a little bit of clarity. That immediately helped me to find the off by 1 error. Depending on the form of the day, you could spot that right away, maybe not. But before you dive into deep thinking mode, just make it simple. Add the debugging output. It will help the interviewer to understand what you are doing actually. You don't want to go silent and just think for yourself. That's because that means not giving any signal to the interviewer, and that's always what's not good. Then we saw that when we ran the test cases, we immediately saw that we have an issue with contracting the window. So we're actually quite fast to seeing exactly what goes wrong. I guess those are good points. And our solutions in every case, in every time, they worked, right? So that's another good signal, I suppose, that even though we had issues implementing a working solution, we were able to fix it on our own. We were quite fast to debug and correct things where things go wrong. So yeah, so that's something that can happen in an interview, even with an easy problem, as you can see. But when that does, don't sweat it. Just trust the process. That's the best thing you can do.